we know that a right triangle with hypotenuse 1 and angle alpha has legs of sine alpha and cosine alpha. We are then going to show you the general right triangle with hypotenuse r, such that the legs are r sine theta and r cosine theta, because each leg is scaled by a factor of the hypotenuse. Now we will move the triangle so that we can then show another triangle with angle beta that is also a right triangle. This triangle has hypotenuse cosine alpha, as seen here. So then we know that because of r sine theta, it is now cosine alpha times sine beta. Then we look at this side of our triangle, a side of cosine alpha, which is our hypotenuse, and times our side, which is cosine of beta. Now we have constructed a perpendicular from this point to this line such that it creates a triangle with angle alpha plus beta. This perpendicular has also created a smaller triangle. We shall call it blue triangle. It has also created a new angle C. I am now going to show a horizontal line segment that is perpendicular to this line through this point. This has constructed a new triangle that we shall call green triangle. This triangle has vertical angle C in it. We know that a triangle with angle C and a 90-degree angle must then have angle B as its third angle. I will now show orange triangle, this one up here. Notice how angle B forces this angle to be C because it is a right angle. Remember that angle B plus C must be 90 because of the 180 degrees of this triangle. Now that we have angle C and a right angle, we must then have angle B as our top angle, because as we've stated before, angle C plus angle B plus 90 degrees is a triangle. Now I will go back to reference this triangle right here. Notice that I can rotate it counterclockwise such that this triangle and this triangle look similar. This general triangle shows me that a hypotenuse must be scaled to our side length. Therefore, we take our hypotenuse, sine of alpha, and we scale it with our side, cosine of beta, to get our side length total right here, sine of alpha, cosine of beta. Now, let us look at this triangle, this large triangle that is a right triangle with angle beta. This triangle has hypotenuse, cosine of alpha. Therefore, its side lengths must have cosine of alpha and sine of beta. Its other side length is cosine of alpha, cosine. Now remember, the objective of this proof is to find the sine of alpha plus beta, such that this is our sine of alpha plus beta. We know this small length right here is sine of alpha cosine of beta. Therefore, we need to know what this and this length are. These lengths plus this length will give us sine of alpha plus beta. In order to find these lengths, let us look at this length. This length is equal to these lengths. Therefore, we can say that cosine of alpha, sine of beta, this, plus sine of alpha, cosine of beta, this, equals sine of alpha plus beta, as seen here. Now let us look for the cosine of alpha plus beta. We know that this long side is cosine of alpha times cosine of beta. But we need to look at this short length right here, not this entire length. So we need to find what this length is, which is equal to this length here. We know that the sine of beta times the sine of alpha via this triangle right here is this length right here. This length, sine alpha, sine beta, is equivalent to this length right here. Therefore, we can say that our cosine of alpha plus beta is this entire length of cosine alpha, cosine beta, minus sine alpha, sine beta right here. We are seeing this via this formula right here. This concludes our proof of sine of alpha plus beta and cosine of alpha plus beta.